The topic is an introduction to problem solving. The first objective in this topic is writing and simplifying algebraic expressions. Our first example, we're going to jump right in. Twice a number plus 3 is the same as the number minus 6. We're going to literally translate from left to right. Twice a number, let's use x for the number. Twice a number means 2 times the number. 2 times x is 2x. Plus 3, that's plus 3, is the same as equals the number x minus 6 minus 6. Twice a number plus 3 is the same as the number minus 6. So that's a little spread out right now. Let's bring it together. And we know how to solve something like this now. We don't have any parentheses to get rid of. We don't have any like terms on the left to combine. We don't have any like terms on the right to combine. So we can jump straight to quote unquote moving around our x's and our non-x's. We want to move the x's to the left. We want to get rid of the x's on the right. We have plus 1x there right now. The single x can be considered a plus 1x. We get rid of that with minus 1x. Subtract 1x from both sides. 2x minus x on the left leaves us with a single x plus that 3. And then the x minus x on the right cancel each other out. That's what we wanted to happen. We wanted to get rid of the x's on the right so that all the x's were on the left. And again, we're not just picking up and moving that x over. We're not saying, hey, this is an x, this is 2x. Together that makes 3x. It doesn't work like that. When we are crossing over the equal sign, we can't just combine them. We have to use the opposite operation to get rid of them on one side so that they show up on the other. We need to subtract the x. And whatever we do on one side, we do to the other. 2x minus x is 1x. Now we want to get the x by itself. We need to get rid of plus 3. We do that by subtracting 3 from both sides. The plus 3 minus 3 cancel each other out on the left. On the right, negative 6 minus 3 is negative 9. So now we know when we literally translate an equation, we can go on to solve that equation. And we can still check the same way that we normally do with just an equation that's not given as a word problem. Twice a number, twice negative 9 would be negative 18. Plus 3, negative 18 plus 3 is negative 15. Is the same as the number negative 9 minus 6, negative 15. Negative 15 is negative 15. This is true. We have the right solution. So recognizing keywords in a percent problem is helpful in writing the problem as an equation. This should be words. 3 key words in the statement of percent problems and their meaning are as follows. So we always want to know in percent problems that of means multiplication. So times. Is means equals. And some form of what will mean the unknown number. So what does this mean? Let's look at an example. Translate to an equation. 15 is what percent of 20? Each of these gives us a different part of the equation. 15 is 15. Remember, is always means equals. What percent is going to be our unknown? We're going to call that n instead of x in this example, but x is perfectly fine as well. Of means multiply, and 20 means 20. So this literally means 15 is what percent of 20? Let's do another. 2.4 is 25% of what number? Now, when we have one of these, the first step is never going to change. The first step is always is becomes equals, of becomes multiplication. Some form of what, in this case, what number, in the last example, it was what percent, is our unknown, is our variable. What number becomes n, and the numbers carry through. Now, when we go on to solve these in future examples, we're going to make another change, and that 25% is going to have to be written as a decimal. It would become 0.25, but we're not there yet. Let's look at another example. Translate to an equation. What number is 50% of 0.6? Go ahead and see if you can do this one. We're not solving for the number, we're just writing it as an equation. So, as always, what number becomes our variable, becomes n. Is means equals, of means multiply. N equals 50% times 0.06, or n equals 0.5 times 0.06. More practice. 3 more. If you want to try these, go ahead, pause, try them on your own, and then play and see what I do. In A, 42% of 50 is what number? 42% times 50 equals n. Of is multiply, is equal. What number is n, or x, or any variable you want, actually, because you're building this equation. And it doesn't specify in the directions what variable to use, which means it's up to you. But if it had said use n to represent the number, then you would have to use n. If it said use x to represent the number, you would have to use x. B, 15% of what number is 6? Sorry, is 9. Upside down dyslexia. Sure, 15% times n equals 9. Of is multiply. What number is n? Is equals. Everything else, the 15% and the 9 carry through. C, what percent of 150 is 90? What percent becomes n? Of becomes multiply. 150 stays 150. Is becomes equals. 90 stays 90. N times 150 equals 90. Okay. So what number is 45% of 80? We start by making our changes into an algebraic sentence, into an equation. And why is it an equation? Because is means equals, and equals is an equation. If there was no equals, it would be an expression. So what number, n, is equals 45% of multiply 80. 80. Now we're actually going to go ahead and find this number. So remember what I said, 45% now needs to be changed to a decimal. So 45% becomes 0.45. Why do we change it to a decimal? Well, because we need to do math with it. Percents need to be decimals before we can multiply. 0.45 times 80 is 36. So n equals 36. 36 is 45% of 80. Let's do another. If you want to try this on your own, go ahead and pause. You're welcome to. First step, take what we have, translate it to an equation. 65% stays 65% of its multiply is equals. What number is n? The 90 stayed 90. Next step, since we're going to go ahead and find the number, we need to do math. 65% must become 0.65. And then 0.65 times 90 is 58.5. So n is 58.5. 15% of what number is 1.2? 15% times n equals 1.2 of is multiply is equal. What number is n? First step in solving, take our percent, change it to a decimal. 0.15 times n equals 1.2. And this time, our numbers aren't on the same side. We can't just multiply with the calculator. We have to get n by itself, which means we need to get rid of timesing by 1.5, or sorry, by 0.15. We get rid of multiplying with dividing. So we divide both sides by 0.15. We get that n is whatever 1.2 divided by 0.15 is, and our calculator tells us that it is 8. Again, 27 is 4.5% of what number? We need to make our translation. 27 equals 4.5% times n. I'm a broken record at this point, but is equals. Of is multiply. What number is n? Now, 4.5% would be 4.5%. So as a decimal, that's 0.045. We start with our decimal point between the 4 and the 5. We move the decimal point 2 places to the left. to get our decimal, 0.045. We need to get rid of multiplying by 0.045, and when we divide both sides by 0.045, we get n equals 600. In example 11, we're asked what percent. Now, when we have problems that say what percent, there's one extra thing we're going to have to do at the end of the problem. Remember, when we're doing our work, we change percents to decimals. So at the end, when we get our decimal answer, we're going to have to change that back to a percent. In the other examples, it asked what number. But when it asks what percent, we need to change it back to a percent at the end. So let's not forget that. But up until that new last step, nothing here is different. Step 1, take what we have, translate it. What percent is n? Of is multiply. 35 stays 35, is becomes equals. 21 stays 21. We have n times 35 equals 21. We want to undo multiplying by 35 to get the n by itself. We undo multiplying by 35 with dividing by 35. When we divide 21 by 35, we get 0.6. 0.6 would be the decimal equivalent of our answer, because all the work happens with decimals. So we need to change 0.6 back to a percent. 60% of 35 is 21, not 0.6%. 0.6 is not a percent. It's decimal that we found by doing our work. It's got to change to a percent to answer the question of what percent. You want to try this one on your own, example 12, go ahead and pause. Come back, see how you did. $35 is what percent of 25? Is becomes equals. What percent becomes n? Of becomes multiply. And we get 35 equals n times 25. We want to get the n by itself. We need to undo multiplying by 25. We do that by dividing both sides by 25. And 35 divided by 25, our calculator tells us, is 1.4. We have to change 1.4 to a percent to answer the question of what percent. Decimal place is going to go 2 to the right. So 140%. Let's look at some applications of percent. For example, wages. %18 of Frank's wages are withheld for income tax. Find the amount withheld from Frank's wages of $3,680 per month. So Frank makes $3,680 per month. Good for Frank. 18% of that gets withheld. So we want to know what 18% of 3,680 is. So when we have a word problem involving percent, the first thing that we have to do is build one of these sentences that we've been working with. In this case, we want to answer the question 18% of 3,680 is what number? Translate. %, times of becomes times 3,680 is becomes equals what number becomes n. We can't do math like that with the percent, so percent becomes decimal. 0.18 times 3,680 equals n. 0.18 times 3,680 is 662.4. So that is our unknown number. $662.40 were held from Frank's wages for income tax, 18%. The principal of Slidell High School counted 31 freshmen absent during a particular day. If this is 4% of the total number of freshmen, how many freshmen are there at Slidell High School? So we want to know 31 is 4% of what total number? And this says method 1. This is a little preview for you that eventually we're going to have a second method of solving these. And we'll get to that. We'll get to that. We're not even halfway done with this presentation. You want to solve this on your own, go ahead. Pause and come back. I'm going to keep going now. Translate into an algebraic sentence, aka an equation. 31 equals 4% times n. Four percent becomes 0.04. We want to get the n by itself. We want to undo multiplying by 0.04. We do that by dividing both sides by 0.04. That gets the n on its own. And the calculator tells us that 31 divided by 0.04 is 775. That means that since n is the total number of freshmen, there are 775 freshmen in the school. So wages was an example of percent problems. Attendance could be a type of percent problem. But another common percent problem is percent increase, percent decrease. To find the percent of increase, we take the amount of the increase and we divide by the original amount. And then write the answer, the quotient being an answer to a division problem as a percent. So the amount of the increase divided by the original amount. The average soft drink size has increased from 13.1 ounces to 19.9 ounces over the past 2 decades. Find the percent increase. So first we need the amount of the increase. To find the amount of the increase, we take our big number, we subtract the small number. 19.9 minus 13.1 is 6.8. So the amount of the increase is 6.8. To find the percent of increase, we take the amount and we divide by the original. It has gone from 13.1 to 19.9, which means originally the original number was 13.1. 6.8 divided by 13.1 is 0.5191, blah, 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 blah. Convert that to a percent, we get about 51.9%. So the amount of the increase divided by the original amount. It's the same for percent decrease. The amount of the decrease divided by the original amount. It's always divided by the original amount. Then write our answer as a percent. John Smith decided to decrease the number of calories in his diet from 3,250 to 2,100. 3,250 seems like a lot of calories per day. Just throwing that out there. Find the percent decrease. So first, we need the amount of the decrease. Big minus small to find the amount. 3,250 minus 2,100 is 1,150. What do we divide by? We divide by the original amount. And originally, he was eating 3,250 calories. So 1,150 divided by 3,250 is 0.3538, blah, blah, blah. Write that as a percent, 35.4%. Now in the homework problems, it'll tell you round to 1/10 of the percent, for instance. In order to get 1/10 of a percent, we need not just the 2 past the decimal point. That'll tell us whole percent. We need 4 because we need to look at this value 8 to determine that the 3 rounds up to a 4. And we get 35.4%. If it had asked for nearest 100th of a percent, we would need 1 more digit on the decimal to look at to get us to 2 past the decimal point in the percent. Okay, now let's take a look at some examples involving sales tax, commission, and discount. This might look confusing at first, but then you remember, I live in a society. I buy things all the time. When I buy things, I pay tax. If I go to a store and I purchase something, the tax I pay is the percentage tax rate times the purchase price. This is real life. So sales tax is the tax rate times the purchase price. And then once I know how much tax I pay, what do I do with it? I add it on to the purchase price to get the total price. Total price is the purchase price plus sales tax. So let's look at these real life examples. A gold and diamond bracelet sells for $1,800, $1,800. Find the total price if the sales tax rate is 6.5%. Okay, so I go into the jewelry store. I see this gold and diamond bracelet. For some reason, I say I want to buy this for $1,800. Okay. They take it to the cash register. They ring it up. The tax rate is 6.5%. So we want to find the sales tax. 6.5% of 1,800 is 6.5% times 1,800. Tax rate times purchase price. 6.5%, decimal goes 2 places to the left. Decimal form of that is 0.065. 0.065 times 1,800, the calculator tells us, is $117. So not only are we buying this $1,800 bracelet, we have to pay $117 in tax. So what's the total price? We add them together. 1,800 plus 117 is $1,917. The total price for the bracelet, $1,917, 1917. Okay, so maybe a bracelet that costs nearly $2,000 isn't something you can relate to. That's a splurge purchase. What if you need to buy a car? This time, the information is given to us in a little bit different of a way. Instead of us finding the sales tax, we are given the sales tax. We want to find the tax rate. So let's let R represent the unknown sales tax rate. Recall that sales tax is the tax rate times the purchase price. Plugging things in, the sales tax is $1,665. The purchase price is $18,500. We want to solve the equation 1665 equals R times 18,500 for R. But take a look at this form. Did we need to remember sales tax equals tax rate times purchase price? That was an easy way to do it. But if we translate this into one of our percent equations, 1665 is what percent of 18,500? We wanted to find the sales tax rate, which is a percent. What percent? What percent of 1,800 is 1665? We could have just set it up using our percent equations. Either way, we end up with this. We need to get the R by itself. We need to undo multiplying by 18,500. So we divide both sides by 18,500. And we get R equals 0.09. Sales tax is always given. Sales tax rates are given as percentages. So we change this back to a percentage. The sales tax rate is 9%. Maybe you've had a job that uses commission, or maybe you're just familiar with how commission works. The commission on a sale equals your commission rate times the amount of your sales. A sales representative for Office Product Copier sold $47,632 worth of copy equipment last month. What is his commission for the month if he's paid a commission of 6.6% of his total sales for the month? So he gets paid a commission of 6.6% on the total sales. So we need to ask ourselves, 6.6% of 47,632 is what? Or we could just plug straight into commission equals commission rate times sales. Either way, we're going to come up with the equation C, or whatever variable you're using, equals 0.066, 6.6% as a decimal, times 47,632. The calculator tells us that is 3,143.712. Why do we need 3 places past the decimal point when money ends with 2 places past the decimal point? It's because we have to look at this third digit to see if we round up the second digit. It's 2. It's not 5 or greater. It does not round up. So $3,143.71 is his commission for the month. So we found the commission. Let's do an example where we get this information and we want to find the commission rate. A salesperson earns $645 for selling $4,300 worth of appliances. Find the commission rate. So we can plug into our commission equals commission rate times sales, letting R represent the unknown commission rate. Or we could look at this and we can say $645 is what percent of 4,300? 645 is what percent of 4,300? It's the same. We want to get R by itself. We want to undo multiplying by 4,300. We do that with dividing by 4,300. Divide both sides by 4,300. Calculator tells us 645 divided by 4,300 is 0.15. As a percent, that would be 15%. Discounts and sales price. Sale price. Again, we live in a society. We go shopping. And when we go shopping, we like sales. We know how sales work. The amount of a discount is the discount rate times the original price. And this is another typo. Don't copy this with a multiplication. This is subtraction. Sale price is the original price minus, not times, minus the amount of the discount. I'm going to fix that right now. You shouldn't even notice. Magic. Fixed. Sale price equals original price minus amount of discount. How did I know that was a mistake? Why didn't I just blindly trust what was on the slide? Again, it's because we live in a society and we shop and we like sales. And if I want to know what the sale price is, I would take the original price and I would subtract the amount of the discount. A $2,000 designer dress is on sale for 30% off. Find the discount and the sale price. So if it's 30% off, I want to know what 30% of 2,000 is. And notice when we plug into amount of discount equals discount rate times original price, it's exactly the same as asking what is 30% of 2,000. To do the math, 30% becomes 0.3. 0.3 times 2,000 is 600. So the amount of the discount is 600. So what's the sale price? 2,000 minus 600. Which is 1,400. Objective 2 in this topic is apply the steps for problem solving, which begs the question, what are the steps for problem solving? And we have this general strategy for problem solving. It's a 4-step process, where in step 1, we understand the problem. Step 2, we translate the problem into an equation. Step 3, we solve the equation. And step 4, we interpret the result. And we very, very much did this in the previous example, in the previous objective. We read the problem. We chose a variable to represent the unknown. We translated the problem into an equation, which we went ahead and solved. And then we interpreted the result. We checked that our solution worked. And we stated our conclusion that we found the right solution. Now, there's more steps to understanding the problem than just choosing a variable to represent the unknown. In order to get that far, we had to read the problem. And if we didn't understand it, we would have had to reread it. In some cases, we might be able to propose a solution and check to see if we can get the answer before making our equation, but we still need to make our equation and solve it in order to be completely correct. And where it's possible, we should construct a drawing that we can refer back to, that we can fill things in on. Let's take a look at another example. The product of twice a number and 3 is the same as the difference of 5 times the number and 3/4. Find the number. So step 1, understand. Read and reread the problem. The product of twice a number and 3 is the same as the difference of 5 times the number and 3/4. We're going to need an unknown number. So if we let x be the unknown number, then twice a number would be 2x. The product of twice a number and 3 would be 2x times 3. 5 times the number would be 5x. So the difference of 5 times the number and 3/4 would be 5x minus 3/4. So now we understand all the parts of the problem. Let's continue. We can now translate the problem. Twice a number was 2x. We wanted the product of twice a number and 3. So we have the 2x times 3. Then we had is the same as, we know that's equals. We know 5 times the number is 5x. So we want the difference of 5 times the number and 3/4. Every bit of that sentence is accounted for in this translation. So we can continue. Now that we have our equation, we're going to solve it. 2x times 3 equals 5x minus 3/4. So we can do a little bit of simplification on the left. 2x times 3 is 6x. So we have 6x equals 5x minus 3/4. Nothing to combine on the left, nothing to combine on the right, left. Correct, correct, right. Sorry about that. I'm having too much fun. Let's subtract 5x from both sides to move the x's from the right side to the left side, or add a negative 5x, however you are thinking about that. But 6x plus negative 5x, or 6x minus 5x, leaves us with a single x. The 5x and the minus 5x cancel each other out, leaving us with negative 3/4 on the right. We have stumbled into the answer of x equals negative 3/4. So let's interpret. We can check. Replace number in the original statement of the problem with negative 3/4. That gives us that the product of twice negative 3/4 and 3 is the same as the difference of 5 times negative 3/4 and 5. So the product of twice negative 3/4 and 3 would be 2 times negative 3/4 times 3. That's 6 times negative 3/4, or negative 18/4, or negative 4.5 if we divide that out. The difference of 5 times negative 3/4 and 3/4. 5 times negative 3/4 would be negative 15/4. Negative 15/4 minus 3/4 is negative 18/4 again. That is negative 4.5. We get the same result for both sides. Our check has worked out. So we know we can state that the number is negative 3/4. So a little bit convoluted there because the number we're checking in the equation was a fraction. The equation already had a fraction in it, so that's fractions on top of fractions. Lots of places to screw up there, but if we're very careful in our work, we can check and get negative 18/4 or negative 4.5 on both sides. Let's look at another example. A car rental agency advertised renting a Buick Century for $24.95 per day and 29 cents per mile. If you rent this car for 2 days, how many whole miles can you drive on a $100 budget? There is a lot going on in this example. So we need to follow the steps. Understand, read and reread until you understand it. Car rental agency advertised renting a Buick Century. The cost is $24.95 plus 29 cents per mile. Understanding that, We're renting the car for 2 days. That means that the number of days are not in question. They tell us 2 days. What they don't tell us, what we're looking for, is how many miles we drove. The question that's asked, the actual question, is how many whole miles. That is our unknown. So that will be our X. And that means that 29 cents per mile, that's 0.29 times X, 0.29X. So if we're building the cost out and X is the number of whole miles driven and 0.29X is the cost for mileage driven, the cost is $24.95 per day, and we have 2 days, so 2 times $24.95 plus 0.29X, the mileage. The days plus the mileage, and it's going to equal 100 because we're told that we have a $100 budget. We want to know how many miles we can get on that $100. So the cost has to equal 100. So it took a bit of understanding to get to that point. But once we understood that we are charged $24.95 per day for 2 days and 29 cents for some unknown number of miles per mile, we were able to build this expression, and we were able to make that expression equal to 100. Let's continue. We take our equation and we work to solve it. We can do some work on the left. We can do 2 times 24.95. That gives us 49.90. We have 49.90 plus 0.29x equals 100. We want to keep the x's on the left. We want to get rid of that 49.90, but we can't just move it to the right. We have to subtract it from both sides. That's how we get it to play with the right side. So subtract 49.90 from the left, subtract 49.90 from the right. The 49.90 minus 49.90 on the left cancel each other out, leaving us with just 0.29x. And 100 minus 49.90 is $50.10, $50.10. The final step, and you'll be using a calculator for this for sure, divide both sides by 0.29. Because we need to get rid of multiplying by 0.29 on the left. That means we need to divide by 0.29 on the left, but whatever we do on one side, we have to do to the other. The 0.29 divided by 0.29 on the left cancel each other out. That's what we want. And when we divide, we get about 172.75. X was the number of miles. The question, though, let's continue. The question asked for a whole number of miles. Now, 172.75, maybe your instinct is to round that up to 173. The problem with that is that if we plug 173 back in, we get 100.07, which is just a little bit over budget, but it is over the $100 budget. 172 plugged in is only 99.78, which is within the budget. And we could have just looked at that answer. If we can drive 172.75 and not anything more than that, then we can't drive 173. The absolute maximum is 172.75. So the maximum number of whole miles we could use is 172. And that is why our answer is 172, not 173. We don't just automatically round. We have to consider the situation in the problem. Let's do another. The measure of the second angle of a triangle is twice the measure of the smallest angle. The measure of the third angle of the triangle is 3 times the measure of the smallest angle. Find the measures of the angles. So as we read and reread, we notice that the measure of the second angle is given in terms of the smallest angle's measure. We notice that the measure of the third angle is given in terms of the measure of the smallest angle. So the unknown that we can build off of is the measure of the smallest angle. Since we're talking about a triangle, we can draw a diagram. And let's let our unknown be that degree measure of the smallest angle. Let's call that x. We're told that the measure of the second angle is twice the measure of the smallest angle. So 2 times x would be the degree measure of the second angle. The measure of the third angle is 3 times the measure of the smallest angle. 3x equals the degree measure of the third angle, therefore. So in our diagram, we have angle measures of x, 2x, and 3x. Since we want to find the measures of the angles, there is one missing piece of information that we should all know as math students, and that is that inside any triangle, we have 180 degrees. It can be split up any number of ways, but the sum of all the measures of all the angles inside the triangle, of all 3 added together, is always 180. So we have the measure of the first angle, that's x. We have the measure of the second angle, that's 2x. We have the measure of the third angle, that's 3x. And when we add those together, that's going to equal 180. So now we have our equation that we need to solve. X plus 2x plus 3x equals 180. How do we solve? We're back to solving again. We combine like terms on the left. 1x plus 2x is 3x. 3x plus 3x is 6x. 6x equals 180. We want to get the x by itself. We need to get rid of multiplying by 6. We do that with dividing by 6. Whatever we do on one side, we do on the other. The 6 divided by 6 on the left cancel each other out. It doesn't leave us with a 0. It leaves us with a 1, and 1 times x is just x. So we're left with the x on the left. On the right, 180 divided by 6 gives us 30. Now let's check that. 30 plus 60 plus 90. X plus 2x plus 3x. 30 plus 60 is 90. 90 plus 90 is 180. 180 equals 180. That works. Now we need to be sure to answer the problem. The problem didn't say find the measure of the smallest angle. It said find the measure of all the angles. So the angles measure 30 for the smallest, 60 for the second, and 90 for the third. To just say x equals 30, or even extending that to say the smallest angle is 30, does not completely answer the question that was asked. We were asked for the measures of all 3 angles, so that's what we must state to be completely correct. Another one. The sum of 3 consecutive even integers is 252. Find the integers. So we know the sum of. The sum of 3 things means we're adding 3 things together. We're adding those three things together, and then it's going to equal 252. That's the easy part to understand. We want to know what these three things are. But we're told that these three things are consecutive even integers. So first, let's talk about consecutive numbers. Consecutive numbers are like 3, 4, 5, 10, 11, 12, 4, 5, 6, 8, 9, 10, 15, 16, 17. Consecutive integers extends that to the negative numbers. So -3, -2, -1, or -42, -41, -40. Those would be consecutive integers. -1, 0, 1. Consecutive just means comes right after each other. Now, to specify consecutive even integers, now we're saying that the three things that are in a row are specifically even numbers. So 3 can't be one of them because 3 isn't an even integer. But if we start with an even integer like 4, then 3 consecutive even integers would be 4, 6, 8, or 42, 44, 46. We don't know what the first one is, though. But if we knew the first one, that means we could get the second one by adding 2. And we can get the third one by adding 2 to that, or adding 4 to the original one. So these are our unknowns. The unknown is, what's the first even integer? Let's call that x. Then the next even integer would be 2 after that. And then the next even integer would be 4 after the first one. So x is the first, x plus 2 is the second, and x plus 4 is the third. If we translate the original sentence, we were told that the sum of the three consecutive even integers is 252. So we are adding these three things together. X plus 2 plus x plus 4 equals 252. Let's start to simplify. We have x plus x plus x. We can combine those to 3x. And we have 2 plus 4. We can combine that to positive 6. So 3x plus 6 equals 252. Let's keep our 3x on the left. We want to get rid of the plus 6. We do that with minus 6. And we minus 6 from both sides. We're left with just the 3x on the left. And 252 minus 6 gives us 246. We want to get the x by itself. We need to undo multiplying by 3. We do that with dividing by 3. Divide by 3 on both sides, because whatever we do on one side, we have to do that to the other. And we get x equals 82. We're not done, though, because the question said find the integers. It didn't just say find x, which was the smallest of the even integers. If the first one's 82, the next even number is 84, and the next even number after that is 86. So the three integers are 82, 84, and 86. And that is it for this topic. The topic is formulas and problem solving. The first objective in this topic is solve a formula for a specified variable. So what is a formula? A formula is an equation that states a known relationship among multiple quantities. A formula has more than one variable in it. So some examples of some formulas that you might need to know. A equals LW means that the area of a rectangle is the length times the width. I equals PRT means that simple interest is principal times rate times time. P equals A plus B plus C means that the perimeter of a triangle is side A plus side B plus side C. D equals RT means distance equals rate times time. And V equals LWH means that volume of a rectangular solid is length times width times height. Now we can apply our methods for solving equations to solve for specific variables here. And it should be pointed out, there is a difference between a capital letter and a small letter. So we've been solving for x usually, and we've usually been using a lowercase x. But if we were suddenly to use an uppercase x, that is not the same as lowercase x. In fact, there are some formulas that use uppercase and lowercase of the same letter in the same formula, but they mean two different things. So I equals PRT has a capital R, meaning interest rate, but D equals RT has a lowercase r, meaning rate of speed. But there might be another formula out there that uses the capital R and the lowercase r in the same formula, because they do mean two different things. So be careful that your capitals are capitals and that your lowercases are lowercases. Don't just make everything capital because you think maybe that looks neater. I appreciate that, but it is incorrect. Okay, so here's this formula, this gibberish formula. Might mean something, but we don't care what it means. Capital T equals lowercase mnr. And we want to solve this for n. Well, we want to get the n by itself, which means we need to undo multiplying by m and multiplying by r. We undo multiplication with division, so we would divide by m r. But we can't just do that to one side. We have to do it to both to keep it balanced. So divide both sides by mr to get rid of multiplying by mr. On the right side, the m's will cancel, the r's will cancel, and that'll just leave us with n. And since there's nothing we can do on the left stays capital T over lowercase mr. And we have just solved this formula for n. So the steps for solving for a specified variable are exactly the same as our steps for solving an equation. We can optionally clear the equation of fractions by multiplying each side of the equation by the least common denominator. This is nothing new. Then we want to get rid of parentheses with distribution. We want to combine like terms on the left, combine like terms on the right. Use the addition property of equality to move, quote unquote, the variables to one side and the other terms on the other. And then use the multiplication property of equality to isolate the specified variable. Oh, it looks like sometimes we're going to use the distributive property to isolate the specified variable. What fun that might be when we come across an example like that. Let's look at this one. Solve for capital A equals or that should say solve A equals capital PRT for T. So not solve for A, just solve A equals PRT for T. We want to get the T by itself. The T is currently multiplied by PR. So we want to divide by PR. We do that on both sides. Oh, I see what happened. This is a mistake. Let me fix it. Okay, fixed it. That should have said solve A equals P plus PRT for T. So there's a P and then there's a plus PRT. So it's not as easy as just dividing by PR. Forget everything I said about dividing by PR. We can't touch that part yet because in order to get the T by itself, we need to get the PRT by itself first. We need to get rid of that P plus in the front of it on the right side. But just like we would get rid of any positive number there, we subtract it from both sides. So step one is to subtract P from both sides. On the right, P minus P will make that go away. On the right, A minus P, that's just going to stay A minus P. There's nothing we can do. Now, to get the T by itself, the T is multiplied by PR, so we have to divide by PR. And we can't just do that on one side, we have to do it on the other. We have to keep it balanced. But again, there's nothing we can do to simplify anything on the left, so it stays as is. On the right, PR over PR cancel each other out, leaving us with just T. So A minus P over PR equals T. In a sense, it's kind of easier to solve formulas because we don't have to deal with the actual subtraction or the actual division. We can just say, hey, these things were subtracted and then divided by this other thing. And then we can just plug in values for A, P, and R and find T directly, as opposed to solving for T with the numbers plugged in first. So sometimes it's useful to solve a formula for another variable. This also wasn't the only variable we could have solved for here. Maybe we were asked to solve for R, which would be a similar process to this. We would just divide by PT at the end. Or more difficultly, maybe we're asked to solve it for P. The P is here twice. So we're going to use a special word for the distributive property in reverse, and that special word is going to be factor. We can factor out a P on the right side here. And all that means is backwards, we would be distributing the P. So we can see this is P times 1. This is P times RT. That's the same as setting up the distributive property P times 1 plus RT. And now, instead of 2 P's, there is 1 P, and we can solve for that P. Divide both sides by, what is P multiplied by? Well, P is multiplied by 1 plus RT. So divide both sides by 1 plus RT. And the 1 plus RT cancels away on the right. There's nothing we can do about it on the left. So P equals A over 1 plus RT.